carbon mass works for us, Hyperpress Technology. Hyperpress cuts CO2 footprint by up to 5 times with Hyperpress bricks. In today's video, we're going to talk about energy-saving Hyperpress technology for bricks, blocks and paving tiles, about CO2 footprint per 1 ton of bricks, Hyperpress technology description, Hyperpress technology advantages, and Hyperpress bricks characteristics. Energy-saving Hyperpress technology for bricks, blocks and paving tiles. At our company, we are committed to building a more sustainable future, and that's why we've developed Hyperpress technology, a revolutionary way to manufacture high-quality bricks with a significantly smaller CO2 footprint. Unlike traditional brick-making methods that rely on burning clay, our Hyperpress technology creates bricks using a unique pressure-based process that eliminates the need for high-temperature firing. This not only reduces the CO2 footprint of our bricks, but also ensures that they are more energy efficient and durable than traditional clay bricks. By choosing our green bricks, you can significantly reduce the environmental impact of your building project without sacrificing quality or performance. Join us in our mission towards a more sustainable future and choose our eco-friendly bricks for your next project. Okay, let's talk about CO2 footprint per 1 ton of bricks. For Hyperpress brick, CO2 footprint per 1 ton of bricks can be as low as 200 kilograms per 1 ton of Hyperpress bricks. For Clinker-fired bricks, it can be as high as 1,200 kilograms per 1 ton of Clinker-fired bricks. CO2 footprint per 1 ton of bricks. CO2 footprint explanation for Hyperpress bricks. Hyperpress technology is a method of producing bricks using high-pressure compaction instead of the traditional method of burning clay bricks. This technology offers significant advantages in terms of reduced CO2 footprint compared to traditional brick manufacturing methods. While it is true that cement contributes to only a small percentage of the weight of bricks, the CO2 footprint of cement is still a significant factor in the overall CO2 footprint of brick production. This is because cement production is a highly energy-intense process that emits a significant amount of CO2. However, the fact that Hyperpress technology uses only a small amount of cement compared to traditional brick manufacturing methods does help to reduce the CO2 footprint. Overall, Hyperpress technology does offer significant advantages in terms of reduced CO2 footprint compared to traditional brick manufacturing methods. But the exact reduction will depend on a variety of factors. To fully understand the CO2 footprint of this technology, it is important to consider all of the materials and processes involved, as well as the energy sources used to power the production process. Hyperpress technology uses high-pressure compaction to create bricks from a mixture of cement and other materials. This process requires less energy overall than traditional brick manufacturing, including less natural gas consumption. This can result in significant reduction in greenhouse emissions and other environmental impacts. CO2 footprint explanation for clinker bricks. The CO2 footprint per 1 ton of clinker brick production can also vary depending on the manufacturing process used, the type of fuel and the specific conditions of production. However, on average, the CO2 emissions for clinker brick production are estimated to be around 0.9 to 0.2 ton of CO2 per 1 ton of bricks produced. It's important to note that clinker brick production is one of the most carbon-intensive processes in the construction industry, and it has a significant impact on climate change and global warming. Therefore, it's essential to consider more sustainable alternatives to traditional clinker bricks, such as those produced with Hyperpress technology, to reduce the environmental impact of building materials. Hyperpress technology can help to reduce the natural gas consumption of brick manufacturing plants and therefore contribute to reducing the dependency on natural gas in the EU. This is because Hyperpress technology uses a different process for making bricks that does not involve burning them in a kiln fueled by natural gas. Reducing natural gas dependency in the EU is an important goal, as natural gas is a finite resource that contributes to greenhouse gas emissions when burned. By using technologies like Hyperpress, which reduce the natural gas consumption of brick manufacturing plants, the EU can make progress towards achieving its climate and sustainability goals, while also reducing its dependence on fossil fuels. Hyperpress technology description. Hyperpress technology is a technology used for the production of chemically bonded bricks without heat processing or autoclaving. This innovative process involves the use of high-pressure compaction, along with binding materials such as Portland cement, to create bricks from crushed stone waste. The raw materials for Hyperpress technology typically consist of stone waste from sedimentary rocks such as shale rock, dolomite, travertine, marble, and industrial waste, like fly ash, coal slag, metallurgical slag, etc. These materials make up around 90% of the total materials used in the process, with cement and water making up the remaining 10%. Unlike traditional ceramic bricks, clay is not used in Hyperpress technology, and the formed brick is not dried or burned. This makes the process more sustainable and eco-friendly, as it does not require high temperatures or fossil fuels for production. Overall, Hyperpress technology offers a promising alternative to traditional brick manufacturing methods, with the potential to significantly reduce the environmental impact of the industry. By utilizing stone waste and reducing the need for high-temperature kilns, Hyperpress technology can help to lower greenhouse gas emissions, reduce energy consumption, and promote a more sustainable future for the building materials industry. Typical Hyperpress mix composition can look like this: cement around 9%, industrial waste 90%, and pigment 1%. Hyperpress technology advantages. Hyperpress technology offers several advantages over traditional brick manufacturing methods. Some of these advantages are: low energy consumption. Hyperpress technology does not require any thermal processing like drying, burning, or high-pressure steam processing. This results in lower energy consumption and greener bricks, which can also lead to lower electricity bills. Use of industrial waste. Hyperpress technology can use different kinds of industrial waste, including mining waste, which can make up to 90% of the total raw material used. This allows for the conversion of waste into high-quality building materials, reducing the amount of waste sent to landfills. Zero waste technology. Hyperpress technology ensures that all raw materials are converted into bricks and blocks, leaving no waste behind during the production process. This means that no liquid, solid, or gaseous waste is generated, making it a highly sustainable and eco-friendly option. Lower investment in equipment and maintenance. Compared to traditional brick manufacturing methods, Hyperpress technology requires much lower investments in equipment and maintenance, making it a more cost-effective option for small to medium-sized brick manufacturers. High-quality products. Hyperpress technology produces bricks and blocks that meet the strictest national and international standards, ensuring superb quality of the final product. This means that the end product is durable and long-lasting, that can be used in a wide range of applications. Hyperpress bricks characteristics. Hyperpress bricks are a type of building materials produced using the Hyperpress technology, which involves pressing raw materials with ultra-high pressure without the need for firing, vibrations, or adhesives. Some of the characteristics of Hyperpress bricks are: wide range of colors and textures available due to the use of different raw materials and pigments. High mechanical resistance ranging from 200 to 750 kilograms per centimeter square. High frost and erosion resistance ranging from 150 to 500 cycles. No limitations as to the number of stories in the buildings. Suitable for use in different climatic zones. High adhesion to mortar, which is 70% higher than that of ceramic building materials. High precision and consistency of face dimensions within 0.3 millimeters. Decorative chamfers and frames along the entire face perimeter of the brick. Carbon mass works for us. Okay, 1200 equals 1200, which means CO2 footprint for 1 ton of clinker bricks is roughly the same to CO2 footprint for 1 ton of Portland cement. 1/10, which means that you need only around 10% of Portland cement to produce 1 ton of Hyperpress bricks. And finally, you save up to 5 to 6 times of CO2 footprint per each ton of Hyperpress bricks produced compared with clinker bricks. You can contact us at any time by sending us a message or filling in a form at our website. Thank you.